I think the recording started. I think we paused recording.
Oh, yeah, it is recording. Yeah.
Okay, then I'll go for it.
All right, hold on.
Okay.
I'm also doing.
Sorry for that. Okay, so we have been working with service provider.
See, you started the recording from here. That's why it's
So
recorded.
we were part of
You
the-
click the recording here,
like
but they can click the. This can.
So we were part of this ecosystem, like NFT ecosystem since the early HC nano days. Actually, we get the seed code contribution for the HC. So from our experience, just want to share some methods and how Nephio can, enhance so that adoption of Nephio can be accelerated. So just want to share some experience around that. So if you go to a service provider and you bring in a new orchestrator or a cluster management tool, or a automation tool, first question they're going to ask you is like, what's going to happen to my current deployment, right? So they will have a existing deployment with all the network functions running. And although they might be having small fires, but yeah, it's running. It's addressing the actual need for the network. So they're gonna ask you the first question like, what happened to my current ecosystem, right? Current deployment. So that's one of the first challenge. And problem with that is most of the telco providers, they will have a multi-year contract with the network function vendor in 5 years or 6 years. So they wanna make sure that all the network function vendor artifacts, basically the network function artifacts, be it or KPI, or any other packaging format out there, can be inherited into the new orchestration or the new tool that one use, be it Nephio or something else. So from our experience, almost 99% of the CNF vendor, they are in a packaging format today. They package their application. So I think one of the first tasks or first challenges will be, or the first question will be, can Nephio support ham packages? Because that's the first question that the provider will ask. So that's the first item you see here. So onboarding the network functions in their current format, which is primarily in ham. Then the next challenge will be API integration. For example, so telco and deployments, it's a big ecosystem, right? It's just not automation or a orchestrator or a cluster management tool. It's a big ecosystem. Your comprises of from the north side OSS, BSS, you will have inventory, then you have an orchestrator, then you have your own individual VNF manager or CNF manager, then you have teams. Teams are, of course, for people who are not aware, it's a data center or a cloud. And you will have a variety of cloud, right? You public cloud, private cloud, and among the public cloud, you will have different variants. Within the private cloud, you will have different variants, right? So how do you fit in? Like in this complete end-to-end deployment, in this complete ecosystem, how do you fit in? So first of all, we need to make sure that the API integration works. And the way the API integration can work is that we have, standards compatibility. So the standards come from HC. You must be familiar about the Soul 5, Soul 3 APIs, and the EMF APIs for inventory integration. So this is the second challenge. So the second challenge is like API integration, so that we can fit in. Once Nephio fit into the ecosystem, we have interoperability with the existing ecosystem environment. And third challenge, so it's not just about deploying the network function. Right? We need to monitor the network functions, and we need to make sure that once the network function metrics process certain threshold, we take certain closed loop assurance action, we scaling, building, and all that. And Kafka has become the de facto standard today. So most of the containerized applications, they expose their metrics over Kafka. So we need an orchestrator or an automation tool which can consume all these network function metrics over the Kafka message bus. And once the operator writes a policy, like when the metric crosses certain threshold, we need to scale up or scale down or do a building action. So the orchestrator or the automation tools should be capable enough, to consume the metric from the incoming Kafka messages and take those. So these are the very high-level 3 challenges we see. I think most probably with the adopters of Nephio, we'll see that too probably. So we just wanted to share our experience on that. And the next interesting thing about this demo is brownfield discovery. So let me a little bit talk about brownfield discovery. So I've been talking about there. So there will be existing deployment, right? Network functions are already deployed, and we are introducing a new orchestrator. So the challenge will be, will the new orchestrator or the new automation tool really be able to discover the existing deployment and take control? That's going to be a major challenge, right? So nobody wants to start from scratch, right? The current deployment will be, I mean, there has been a lot of effort, man hours put in to get the system going, and it's up and running. So when you introduce a new tool, new automation tool, or an orchestrator, we would like to take control over the existing deployment. So the prompt discovery is a feature around that. So how it works is like it kind of crawls your data center, tries to figure out what our network functions are currently running, tries to figure out the networking aspects of the network functions, how they're connected to each other. And once you click on discover, what it does is automatically discovers the network functions, build the TOSCA models for you, and also it builds the network service descriptor for you. And once you click on prompt to discover, it kind of takes control. So by take control, I mean the network functions are already up and running, but the orchestrator was introduced later, and it kind of took control of them so that the next lifecycle management events, the scaling for those network functions, can be done through this newly introduced orchestrator. Yeah, so these are the two challenges we saw primarily in the telco providers, and we have to share our experience with that. Yeah. So we should consider this probably next week. Moving on. Okay, so yeah, so I have a live demo of how it works. Let's see, a lot of connectivity issues today. So we took the OI 5G RAN network functions to Sagar chart. So we took the OI network functions and we converted them into our orchestrator. So the orchestrator, the way it works, once you import the ham chart into the orchestrator, it kind of do a sanity check of the ham chart, whether the way the things are defined in a ham chart, whether it is primarily correct, syntax is correct. And once that is done, it generates the TOSCA template for you. And once the TOSCA template is generated, you get a CNFT and a network service descriptor. And with the descriptor, once the descriptor is generated, you can actually instantiate or do a routing discovery if required. And now that your network functions are exposed in a way that is interoperable to the existing environment, it's easy to connect with an external inventory manager or to the EMF APIs. And it's easy to do the closed loop assurance through the source-file APIs for scaling, building, and all that. These are a few snapshots from our orchestrator, the running network stories. Okay, let me switch over to the live demo. So we have Nephio cluster added here for data center. So and have discovered all the resources. See this discovered 9 seconds ago. So what it does, once discovery is completed, we kind of crawl the data center, try to figure out all the resources that's up and running. So if I go to resources, you will see here is the CPU, here is the TU up and running. And you get to know about interface and interface, containers, and all that. Okay. So this is up and running. And now, say I want to do a route discovery. So what I do, click on generate CMFT. So this generates the TOSCA template for you. Okay. So here you select release name. This is a hand release, so this can be expanded tomorrow to KDP or other operators. So you select this, and once you click on this, you click on generate. So the system automatically generates it crawls the data center, tries to figure out how the network function looks like, how many containers it comprises of, how many pods, and the deployments and all that. Once that is done, it generates the TOSCA template for you. Okay. Click on generate. here. So once it is generated, you can go to the catalog. Catalog, you'll see the generated TOSCA tag. So here it is. So there is a CU, there is a DU, there is a connect, and ref. Get inside it, it's like it comprises of one microservice, one connection point. So this is what the TOSCA model looks like. So that from an from the ecosystem point of view, when a Soul5 API tries to do the scaling or building on a CNF level, it can do that because now we have the TOSCA format and the TOSCA modeling of the network. All right. So when I was talking about compliance network service, so in actual world, in actual deployment, we have seen like network service comprising of 50 CNF, right? Complex network service with multiple networks of like for SRIB and all that. So this is fairly simple. This is comprising of 2 CNF. This is the OI50N. Must have seen this earlier. So this is a TOSCA model for that. There is CU and there's DU. They are connected over the Kubernetes default. Yeah. So let me do the prompt discovery. Do that coding here. Discovery. So the way it works, you can click on map existing resources. You set it to true. Okay. That means I don't want to start my network service from scratch. Rather than that, I want to map with the existing deployment and take control. Okay. It's asking which data center you want to deploy. This is the cloud basically. Adding a few cluster here. So yeah. And look at this. So this is asking for discover the resources. Okay. So it's asking me like click on the discovery button so that the system can figure out like what things are running today. So here it is. It's asking for a release name. So this is the data you see. This is actually pulled from your cloud. Okay. This is the running network function. That's it. So if you click on instantiate, the system tries to take control of the running network function, and later on, once it has taken control and the blocking discovery is successful, next any action that you do on top of this, scaling, building, and other advanced consideration, will be done on the existing running function. Okay. So that's how blocking discovery works. Actually, we had a working methodology to happen. We are trying to expand it to other packaging format that we can operators. Working on it. That's what I have for the demo. I have a question for you. Yeah.
So how did it recognize the existing services?
Sorry, I missed the.
Thanks so much for how you said discover how to actually recognize the existing services.
The mic on the clicker's on the bottom. There's a switch on the bottom. I don't think it's on. On that bottom right.
I was curious about when you did the brownfield discovery. First of all, thank you so much for the demo. Curious when you take the discover the existing services in the brownfield deployment. A couple of questions. How did you discover that? Because was your system already aware of that? Those services. And then from, let's say you want to switch between the existing service and the new service that you add. You see in this particular case. How does that work?
So there are varying degrees of that depending on what information is available. The most basic is that if no information is available or in the database or anything that you pull from, then what you would end up doing is instructing the orchestrator, where certain things are and how you would map them. That's the most basic. And there are more sophisticated ways of doing that. So for example, you can solve databases or do smarter things than just doing that. But there are various ways of doing that effectively. But the idea here in the end is that you want to be able to take a model of the various assets that are being deployed by a service provider, and then being able to reconstruct a service object, which is a higher layer model, and then be able to manipulate that upper level object in the same way that you would manipulate all the lower level objects as well, which is why, having consistency of using TOSCA and a good hierarchy of models that allow you to manipulate at each level is, vitally important.
Thank you so much.
How about the greenfield? You showed the brownfield. How about the greenfield case?
Greenfield is actually the easiest case. It's just basically instantiate and instantiating. So in Greenfield, it's you're basically starting from scratch with nothing. So you're just instantiating. Everything starts from the models again, right? So we I think in the catalog we would have different model again, the whole model hierarchy, right? So you would have the network service descriptor and the function descriptors. Normally for service provider, you would be instantiating the network service, which is the end-to-end service, like an entire 5G service in the case of slicing. So in Greenfield, you would just be deploying it. But when you have existing assets that are pre-deployed, like, we talked about virtualized applications today, but you can have actual physical routers that have deployed that you need to connect the service to. That's the more interesting case and more real world use case where you would actually be mapping that network service onto actual physical assets, or if you can deploy virtual assets and then taking control. But Greenfield is actually so
For core or radio, because for radio sometimes in real world radio or greenfield is complex.
It is.
So it's not exclusive as well. It's not like we were just doing from or grid. So we can combine it. So say for example, if I show you this picture is it's comprising of two CNF. Right? So say for example, for the CA, you want to do groundfield, and for DA, you want to do groundfield, greenfield, sorry. So that's possible. Like you can do that. Like you can do a mix and match of both greenfield and brownfield at the same time.
Hi guys, I'm Paul. I'm one of the people working on TOSCA 2.0 right now. I'm also a maintainer of the Chile TOSCA compiler, Toronto, which is the Kubernetes operator for TOSCA, and Cthulhu, which is the reimagining of Kubernetes with TOSCA topologies and service composition in mind. I just want to point out that kind of trying to not in the last Nephio developer forum, I showed a demo also of TOSCA working on Nephio. And I'll say there's inspiration both ways. I'm currently the co-chair of the automation sync in Nephio. Many of my thoughts about TOSCA, I think, come into my proposals for Nephio. If you saw Wynn's presentation yesterday about dependency management, that's very native, right, to the TOSCA requirement. But also ideas that I learned in Nephio in the past year have also made their way into my proposals for TOSCA 2.0. So I encourage people who think a lot of TOSCA was very related to Etsy and the NFU profile. We moved way beyond that. With 2.0, we really try to break away from that idea of TOSCA as a descriptor and really as an in-depth cloud-native language for describing topologies, right? So 2.0 is supposed to be a fresh start. We purposely are breaking compatibility with the previous version of TOSCA, like 1.3, and I think it has something new to offer for people who have certain preconceptions about what it does. So if you didn't get a chance to see my demo from the last developer forum, you can come to me and I'll show you how to connect it. The focus on that demo was really about topologies. Right, so TOSCA has, we see topologies all across cloud, right? That's the T of TOSCA, right? From the infrastructure level, to the workloads, network functions, all the way to the and a multi-sided network service policies, right? So sometimes in Nephio we talk about network services which are not in scope, but we do stitch together network functions in order to create the basis for network services, right? So that's kind of where the interest right now is in Nephio with the topologies, but I think Nephio has to offer deeper as well with the dependency management, etc. Hopefully the strengthens your argument here. Very happy to see you guys more involved in that,
Absolutely fine, so.
Yeah, let's wrap it up. Thank you so much, Tom, for verifying that conclusion that TOSCA 2.0 has no deep connections with FC NFB, and it would be a fresh start. The reason I wanted this presentation to come to this forum was to share on what the existing brownfield looks like, and within TELUS we have been using TOSCA for quite some time, and I'm one of the supporters of that model. Because in the reality, when we deploy a complex 5G network with 85+ microservices, that's one way to abstract that complexity expressed as an object to an API upstream. So I think more powerful ways to do that through TOSCA, and I think one of the things that Tom also mentioned, the abstraction and the topology representation. Thanks.
Okay, we are running short on time, but I think we have one last quick.
I have a bit of a controversial one, so that's why I wanted to, because I think the value of Kubernetes is distributed actuation. And I think you're going in, value to TOSCA is basically a centralized proposition, right? And I think my personal view is the reason why Kubernetes is so successful is because of the distributed nature of deploying complex things, right? And I believe if you look at it, that means that maybe that I don't say that you don't need the central component, but the way that the dependencies are resolved has to be resolved in a distributed fashion. And that's a very different way than how TOSCA is today composed. So the way I look at it, and that allows us to do this because it's a complex composition, but you can actually decompose it into multiple building blocks that at the end of the day are instantiated and in distributed locations. And I think we have to find a mechanism to allow that, because then we can actually scale in, scale out, doing various operations become way more easy and less, we have more dependencies on central components.
Yeah, I think that's a very good observation. However, I think we're going to be running out of time if we address it here, but I'd love to speak to you about that afterwards. I think there are also different, different types of management that is introduced in the service provider network, which is that I think that and that's why we see a difference between very cloud native deployments that are still making their way into many service providers today. So this is of course one of the most advanced, but it's a different mindset. It is, and managing that migration is actually the key part, because it doesn't happen overnight, right? So anyway, I'll leave it at that in the interest of time, but thank you all for your questions. Thank you very much.